So a couple weeks ago, I posted this video on Instagram and I got a few requests for more information about what tools I was using. So yeah, AI is kind of hot right now, has been for at least a year, maybe longer depending on what your metric for hot is, but it's here and people are using it, so how can we use it to make music? That's what I want to talk about in this video. So AI is actually not that great at making songs yet, but it's really good for making interesting sounds. Today what I want to look at is a tool called Diffusion. If you are familiar with the world of AI tools, you may have heard of Stable Diffusion. This is a fork of that project by a company called Harmony. It works on the same principle as Stable Diffusion, but it works with audio instead of imagery. And it's not bad. Diffusion uses models based on large sets of training data to spit out new audio. And it does this largely based on what you put into it. So we can actually train our own models on our own sets of data. Before we actually start working on that, I want to lay down some ground rules. First of all, I will not be training these models on the music of any other artists. And the reason for this is because when we are working with relatively small sets of data, there's a pretty good chance that the AI will just pull out like a direct sample of something that we fed into it. And we don't want copyright strikes for any of this stuff. We're trying to keep things generally above board here. Rule number 2, I am only going to use sounds that I find on Splice or sounds that I have made myself. And rule number 3, since I'm going to be using a lot of sounds that I found on Splice that I did not create to train these models, I will not be releasing any sample packs or selling anything that is generated during this session as my own. Now, these sounds might end up on an official release, like if I make a track with them. However, I see that as no different than if I were to find a bunch of sounds on Splice and do my own stuff to them, whatever process to make that my own, and then put those in a track and release it. So no sample pack. Okay, so now that we've laid the groundwork for this, let's take a look at the actual process. And just a heads up, the next 15 or 20 minutes are going to be some pretty heavy, dense tutorial content. So if you just want to hear some of the sounds I'm making with this stuff, skip ahead to the time on the screen. So Diffusion currently runs on Google Colab, which is an online tool that gives us access to computing resources from Google and GPUs and stuff like that. There's a few different steps to this process before we actually start generating audio. So we're going to need a few different pages that I have links to in the description. So you're going to want to open those up and follow along. So first, we need to make an account on Weights and Biases, which we will link to Diffusion later on. This will basically become our hub for tracking all of our model training and accessing the audio files that we generate in the process. As you can see here, I am able to see all of my training runs. And if I click on one, I can actually see all of the stats and audio generated during the process and stuff like that. But basically all we need is to be able to click this download button once we have our generated files that get spit out, but we'll get to that later. So make a Weights and Biases account, and then we will return to that in a minute. The next thing we need to do is actually collect all of the audio that we want to train the model on. So my process for this was to go to Splice and create a few different collections that I wanted to train different models on. So here's one, for example, that I train on a bunch of like ridiculous, noisy, glitchy dubstep basses. Etc., that kind of thing. So I just went through Splice and found as many as I could. And then once I had those all in a collection here, I just downloaded them all to a folder on my hard drive. Now, unfortunately, I couldn't find a way in Splice to just download them all at once. So I actually had to individually drag them over, which was kind of painstaking. But I did it. And it was honestly worth it. So once you've got those downloaded, we need to go into our Google Drive, and I have created a folder called AI Training Data, and I've uploaded them all into that folder. And then once that is done, we need to go to the chunking page, which you should be able to access through the description of this video. So the way Google Colab works is that there are little snippets of code that you can execute by pressing these play buttons on the side here. And that's how all of these pages are set up. They're just a series of code executions that you have to work your way through. So on the chunking page, first we need to mount our Google Drive. So we'll click that first one. It's going to ask us if we want to connect to Google Drive. We'll hit connect. We choose the account that we want to connect, and then we hit allow. And then it's going to take a minute to do that. Once that is done, we are going to install some of the stuff that we need to run. And then once this button here turns into, it'll show you like a little green check mark. Cool, so that's done. And then this is the part where we actually point it to the audio files that we want to chunk. So the reason we have to chunk it is because the fine tuner will look for audio that is exactly 65,536 samples long to train. So we need to make sure that all of the audio files are split into that size of chunks. So we need to go down here to this path right here, and we need to point it to the folder full of all of our sounds. Now, I've already put in this path here, but the way that I did that was I went to this files section over here, open up drive, my drive, AI training data, bases, that's the folder we want. So I just click on this right here, copy, and then paste, and there it is. And then we can just create another folder called chunked bases. This will actually make a new folder on our drive called train, and that is where it's going to dump out all of the chunked folders that we can use when we train it later on. So once we've got all this put in, I'm going to click this play button, and there it goes. So there's a lot of ones that it's actually going to end up skipping because they are considered silent, but that's okay. We really do end up getting plenty of stuff out of this that we can train our model with. Okay, now that's done. Now we can move over to the fine-tune page. So on the fine-tune page, what we need to do is similar to before. We're going to have all these code snippets that we need to execute. So we will start by checking the GPU status. There we go. And then we will connect to our Google Drive again. Connect to Google Drive, choose an account, give it access. It's also going to save the models that it generates to Google Drive. You can have those saved to weights and biases as well, but I've just been saving them to Google Drive. That's fine for me. Then we need to install the dependencies. So let that run for a bit. And then once that finishes, it's going to tell us that we have to restart the runtime in order to use any of these newly installed things. So we'll hit restart runtime. And then we need to log into weights and biases for run tracking. And so this is where we will go over to weights and biases, and we'll go to wnb.ai/authorize. And this is where we can get our API key. And then on the fine-tuning page, we paste it right here, hit enter, and then we're logged into weights and biases. Now, the last thing we need to do before we actually start training the model is we have to have a checkpoint model to start from. Now, I was trying to set up some kind of like wget thing that would just pull it right into your Google Drive, but I could not get it working for the life of me. So the easiest way that I have found to do it is if you go into the Dance Diffusion page here, the main Dance Diffusion page, and then you open up the part where you get to create the model and choose the model that you're going to be generating from. If you double click right here, you can actually find the links to the other, you can find the links to the models that are included in Dance Diffusion. And if you just copy one of these, I'm going to use this glitch 440,000 iterations model. And then it'll let us download that whole checkpoint file. It's pretty big. It's like 3.3 gigabytes. So yes, this is going to take a while. Let's let it download. And then we're going to have to upload that to our Google Drive. So patience. Okay, so now that that is done, we can go into our Google Drive, and then I've created this models folder under AI. So AI models, and then I'm just going to drag this checkpoint into there. And now it has to upload. So again, patience. Okay, it's done. So now we can go back to the fine-tune page and start to fine-tune our model. So I'm going to call this DD bases. And then we need to point it to the training directory with all of the audio. So that's going to be this one, chunked bases. I'll copy that path and put it into there. And then we need to point it to the checkpoint path. So that's going to be this one right here. Might have to refresh the file browser to get that to show up after we uploaded it. So that one is going to go right there. That's our checkpoint. And then we need to give it a path to save the outputs. So we'll just it'll just automatically make a new folder in this models folder called Dance Diffusion and Fine Tune, and that's fine. We can just save it in there. It's going to output an audio demo every 250 steps, and then 500 steps for saving model checkpoints. So, and let's do the sample rate of 44,100. Number of audio samples per training sample. This is what we set earlier. I'm going to turn off random cropping so that it always starts the training from the beginning of the sample. And now before we hit play on this, I've noticed this issue with this specific page is that it doesn't seem to want to pass these path entries, these field entries into the actual part of the code here. So I've actually just been copying these strings over. So this one goes here, and it's a string, so it goes in quotes. And then training directory, that one is also a string, so that goes in quotes. So we'll copy that. Whoops. Copy, paste, and then sample size is going to be 65536, and that one is not a string, so it doesn't need to be in quotes. Batches, accum batches 4, and then sample rate be 44,100. Batch size is going to be 2. Then demo every 250, and then checkpoint every 500. And I'm going to delete this line because we're not saving to weights and biases. And then this one we can just leave as is. And then we need the output directory. That's this one right here. And again, it is a string, so it's going to go in quotes. And if anybody knows of a way, anybody watching this knows of a way to fix this so you don't have to do that every time, that would be awesome. But I haven't figured it out yet, so that's what I've been doing. So once we've got all those entries in the code there, we can hit play. And it's going to take a second, but it should start training our... There we go. Yes. Okay. And it's running. So that is that's all we need to do. And now we just wait, and it'll just keep training these models based on our input there. And there we go. We're off. Okay, so a little bit of AI and machine learning vocab here. A step is every time it trains the model on one of the files that we fed into it. And an epoch is once it has trained the model on every single file in the data set. So you can see here there were 1,078 files in the folder that we gave it. So one epoch will be once it has trained the model on all 1,078. So yeah, now we just let that run, and it takes some time. So go, make a cup of coffee, go to the gym, I don't know. Okay, so I've had this running for maybe an hour and a half, something like that, and I'm going to check in on it right now. So it looks like it's been training the whole time, which is great. If we hop over to our weights and biases page, we will see that we now have some audio. So we can actually scroll through the iterations as it's been training and see the different demos as the model evolves. So this is where the model started. This is the model as we got it before we actually did any training on it. And then if we hop ahead to the most current iteration, this is where we're at now. So we're getting somewhere. I'm going to let it train for a little while longer. But one thing I wanted to mention is that as these model checkpoints are saved to your Google Drive, they're huge. So if we go into the fine-tune folder here, we'll see that they're each 3.3 gigabytes. That's huge. So if you don't have any extra storage on your Google Drive, that's going to get used up really quick. I'm just going to delete these because I don't think we need those early checkpoints right now. So I'm going to delete those and then go to the trash and empty the trash. and refresh. And now we've got some more space on our drive. So I'm just going to keep doing that as the models get trained, just so we don't fill up our Google Drive, because then it'll just stop training. Okay, I'm going to take another break and see where we're at in another hour or two. Okay, so it's been running for maybe another hour, hour and a half, and this is where we're at. Pretty cool. Let's take a look at maybe the previous iteration. Perfect. Okay, so I think we can just stop the training now. This is pretty good. Looks like that last iteration was number 441,501. So if we look in our fine-tune folder, this model checkpoint here was around 441,500. So that should be fine. So we can go back to our fine-tune page and just click that stop button, and it's going to close out the training process. Give us some stats there. So now we can take this checkpoint file, and I'm going to move it to our main models folder. And I'm going to call it bases. So now this is our bases. I know they're not really bases, they're just kind of crazy sounds. This is our model that we can use to generate sounds like what we fed into it. So now if we go to the Dance Diffusion page, we can do kind of something similar to what we did before, except this time we are going to be pointing the Dance Diffusion generator to that model that we have just put on our Google Drive. And then we can specify how many samples we want to spit out, the length of the samples, et cetera, et cetera. And we can even give it a sound and then tell it to regenerate that sound using the model that we've created. So let's start kind of like we did before. We will install the dependencies. Okay, and you'll see this thing where it says your session crashed for an unknown reason. That is to be expected. The person who made this actually made it crash so that it would restart, because I guess they probably just didn't trust people to restart the runtime, which is necessary in order to get all of these dependencies working after installing them. So now we can move on. So check GPU status, connect to your Google Drive, and then it's just like before. Choose an account, hit allow, and then just keep working your way down the page. Cool, so that's done. Once we get to the model section, we're going to choose custom, and then we can choose the path of the custom model. So we need to go to our drive, my drive, AI, models, and bases.checkpoint. That's going to be the one that we use. So copy the path, paste it there. Sample rate is going to be 44,100. Sample size is what we had it set at before. Hit the play button. This will take a minute. Okay, and then once that is done, we can choose the sampler that we want to use to generate sounds. And I actually don't know a single thing about what any of these do differently from each other. So I have just been using the DDIM. I don't know. That's just the one that I've been using. I'm not sure what the advantage is for any of them, but I mean, I'm sure they produce slightly different results. So feel free to, knock yourself out, go explore. So we need to hit the play button, choose the sampler, and then here we can choose how many audio clips to create, the number of steps. I'm actually not 100% sure what the number of steps is. I think that is the generator like iterating on samples. I don't know. It just says like more steps trades off speed for quality, so it takes longer, but it might sound better. And then sample length multiplier. 1 is the default. They're roughly 1 second. If we enter like 10 here, they might be like a little bit longer. It doesn't seem to correspond linearly, but yeah, higher number means longer samples. I'm going to do 2 seconds or 2 multipliers of whatever the original one is, and then we can choose to save the new generations to weights and biases. So let's hit play, and now it's just going to work its way through this through these steps, and then once that's done, we'll be able to hear the sounds that it spits out. So now we wait. Okay, so let's see what we got. Cool. Not great, not terrible. Sometimes it's a crapshoot with these things, and like I said, you can experiment with different models here. It also is worth mentioning that the first time I trained a bunch of these models, I did not use the Glitch 440K model. I actually used the J-Man Small 190K model. And I think I got better results than what I'm getting with this one. So that's worth mentioning too. But yeah, so there are a lot of variables here. You can change the model you start with. You can change the material that you feed it, you can change how long you train it, and you can change any of these settings that I do not know what they do at all. It's worth messing around with to see what results you get and experimenting with that a little bit. Before we move on to looking at some of the things I've been making with this tool, there are two more things that are worth looking into if you're interested. First is Sample Diffusion. This is a command line interface version of Dance Diffusion that you can run locally on your computer. So you can download the models that you've created and put them in a folder and have this command line tool generate audio from those on your computer instead of using Colab. So that's worth looking into if you're interested. All of the instructions for installation are listed on the GitHub page that I will link in the description. It works on Macs and PCs from what I can tell. I was able to get it working on my Mac pretty easily. I just had to install all of these dependencies that it lists. And then there is another tool called Sample Diffusion GUI, which is a graphical user interface version of Sample Diffusion. I could not get this to work on my computer, so I gave up on this one. But if you have a PC, this might be a really great tool for you to install and mess around with. Okay, so now I'd like to share some examples of the audio that I've been generating with a few of the models I've trained over the past couple weeks. The first one is trained on selections of my discography. I took my favorite tracks from the past maybe like 7 or 8 years and put them all into a folder and fed that in. So here are some examples of the audio that I put into the model. And here's what I got out of it. Honestly, I kind of love it. It has like the essence and texture of my music, but obviously the patterns and the timing and the actual coherence of it is not really there. So there's a lot of potentially useful material there that I obviously wouldn't come up with myself, but it still sounds like me. I think that's really cool, and I think that has a lot of creative potential. The second model I trained on a folder of drum breaks. Some of them were found on Splice and some of them were from my own library. And here's the output. And I just think that is like the coolest thing ever. There's so much usable material there. It's perfect sample fodder for one-shots. There are a lot of really interesting textures in there, like this part, or like just little bits like that. And then there's also a lot of really great, just like that. There's a lot of texture in that kick. Lots of little like things that could be used for drum fills, or there's just so much to work with there. I love it. This next model is actually the same data set that I used earlier in the tutorial part of the video, but instead of using the Glitch 440K model as a starting point, I used the J-Man Small 190K model, and I think the results are better than what I got in the tutorial. So if you're going to do this, I mean, you can experiment with both, but just be aware that the results might vary a little bit. So here's what I fed into that one. And here's what we got out of it. It's just insane. There's so many potential uses for this material. I love it. This next one was kind of, I wouldn't say a failure, but I didn't get quite the results that I was expecting. I'm not sure what I was expecting exactly, but this one I fed a bunch of ambient dub textures and field recordings and things that have a lot of like ambient chord textures. Here is what I fed into that one. And then what I got out of that one is this. I guess the reason I like those types of sounds is because they're so clean. But the AI dance diffusion stuff, it has this like dirty element to it. It doesn't really sound clean and crisp. It sounds like crunchy and garbled in a certain way. And I think it lends itself well to certain types of sound design, but other types it just doesn't quite work for. So, you know, we would probably just want to use the right tool for the right job if I wanted to get these dub textures. I don't want to say that it was a failure because I still think there's some usable material in that output set. The next model was trained on a large folder of vocal samples like these.
You and I will find each other. Love me like I love you.
And here is what I got out of that one. So this output sounds like it's a lot more in the uncanny valley territory than any of the other stuff, and I think that's because as humans we have a very nuanced way of listening to the human voice. We can pick up on the slightest nuances of timbre and intonation and contour, breathiness, and things like that. So when something deviates from what we're used to hearing with the human voice, our brain instantly goes like, that's wrong. And I think that's what's happening here, which is a really cool effect because none of these are really human sounds, but they do sound human-like. So yeah, I think this one has especially a lot of creative potential. And the last model that I trained was on a set of IDM textures and synths and drums and things like that. And here's what I got out of that one. Again, tons of usable material there. I think this one is probably some of my favorite. A lot of material in here that we can chop up and repurpose in our own way. So now let's take a look at some of the stuff I have done with this material. This is the track that I showed at the beginning of the video. Let me just walk through what the AI stuff is doing in this track. So I have this group called AI Drums, and this includes a bunch of drum breaks and chops. It's all from the drum breaks model. Even that like cool texture part in the background there. That's just a small section of it that didn't quite have any drum hits, but it still had this cool swooshy kind of sound in it. So I took that and I chopped it up and just kind of peppered it in kind of wherever to give it some interest. I also reversed it occasionally. So here is the whole AI Drums group doing what it's doing. And then later on in the track, when the actual kind of like drop section hits, there's this little fill, and then it leads into the next section, which is made up of a different set of chops from the same model. I was also able to get these like almost record scratchy effects here. And those were actually made out of the output from the model that was trained on my discography. I also have this additional thing that I pulled. I think this was from the dub textures model. And I just looped it. It was just like kind of a long held out ambient tone. And I just looped it and put it in the background. And it continues throughout the drop. That's what the AI is doing in that track, which I'm pretty pleased with. I think it sounds good. So this is another track I've been working on. This one is kind of a dubstep leaning track. And the way I started this one was just by listening to the output of the basses model and finding sounds that I like and kind of just looping those and chopping them up to arrange them over a dubstep beat. So all those sounds are made from the AI output. So when you put those in context over the whole beat, it sounds like this. And a lot of these sounds have some additional processing on them, like maybe some compression or reverb or delays, but they are really, really awesome starting points for sound design if you are stuck or if you're just trying to break yourself out of a rut. I really think that these are awesome idea sparks, especially if you tailor these models to your own taste. You're going to get results out of them that are specific to you, so you can kind of build your own AI arsenal of models to aid yourself almost as digital collaborators for your creative process. So yeah, this is where I'm at with AI stuff right now. I think it's a lot of fun. I think it's about to become a really valuable tool in music production. I think that the fears about it are valid, but I think that we as artists have an opportunity to claim it as a tool for creative expression as well. That's everything I've got for this video. If you're interested in seeing more content like this, hit the subscribe button. Do me a favor and hit the like button so that the algorithm favors this. And I'll see you next time. Thanks for watching.